Hello everyone. Can everybody see my screen? So can everybody see my screen?
Yeah. Yes.
And can everybody hear me?
Yes. Yes.
Okay, so then I'll move on. So today we will doing like counting and stuff. So by the way, when you're solving quadratics, we can use the quadratic formula, which is this. And when the discriminant, or this part, is negative, the quadratic will have no real solutions. And if the discriminant is 0, it will only have 1. And we can also solve it from completing square. Okay. So, counting bowling pins. So, if there are n rows of bowling pins, how many are there? That is the question that we will eventually want to answer. So, this is called the nth triangular number because bowling pins are like 1, 2, 3, and then 1, 2, all the way up to n bowling pins. So obviously, this is an equilateral triangle, so that's why it's called a triangular number. You can also treat it as an arithmetic series, which is 1 plus 2, wait, no, sorry, plus 2 plus 3 plus all the way up to plus n, which is obviously an arithmetic series with common difference 1 in first term 1. You can also treat it geometrically because suppose that we just put one of them here and the other one upside down like this. So obviously this is a parallelogram. So there are 1, 2, 3, 4, 5. In this case, when n is equal to 4, we have 5 rows. And if there are n, then there are n plus 1 rows. Because there are n of these right here, and we have an extra one right here. So there are n plus 1 rows. N plus 1 rows. And each row there are n, so times n, and then over 2. So this would be our formula to this question right here. And I'll give you guys a few minutes to solve this problem. Okay, so I'll go over these problems now. So for the 11th triangle number, it's just 11 rows of bowling pins. So it's just 1, 2, 3, 4, 5, 6, 7, and so on. So it's just an arithmetic sequence, 1 plus 2 plus all the way up to plus 11, which is just the sum of the first two terms times the number of terms over 2. So it's just 12 times 11 over 2, or 66. And the formula for the nth triangle number is just this right here. N plus 1 times n over 2. Questions? If none, then I'll move on. So, for handshakes, it's just essentially the same as the previous one, because suppose that there are n plus 1 people at a party, and everyone shakes hands with every other person. So the first person shakes hands with 11 n of them. Second person shakes hands with n minus 1 of them, because in this one, the second person has already shake hands with the first person. So all the way down, up to the last person, the second to last person, that can only shake hands, that has only one, because he's already shaken hands with all of the people above. So like that, there's only one for the second to last one. So it's technically just this, but we have n is n minus, but we have, and we have, like, the formula is just n times n plus 1 over 2. For n plus 1 strangers meeting up and shaking hands. And you can also derive this like this. So, suppose this time we have n people. We have n people, and we have that every person shakes hands with every other person. So every person shakes hands n minus 1 times. So it's just, the answer is just n times n minus 1 if there are n people. This is obviously not true, because this doesn't match with this. Then what's going on? Because every person does shake hands n minus 1 times, but it's still not the same as the formula we derived above. Why is that? That is because that every handshake is between two people. So every handshake is counted twice in here. So we would have to divide 2 in order to get the actual formula. So I'll give you guys a few minutes to solve these 2 problems.
Wait, is it 66?
Okay, so I'll go over them now. So 12 strangers meet up. If everyone shakes everyone else's hand exactly once, how many handshakes have occurred? So for this problem, we have that there are 12 people, so it's just 12 times 11 over 2, which is just 66. Any questions for the first one? And the formula for n strangers we calculated, it's just right here. So I'll move on. And these are some in-class problems. So I'll give you guys a few minutes to solve them. And yeah. Okay, so I'll go over these problems now. And so, for the first one, we have several couples arrive at a dinner party. And each person at the party shakes the hand of every other person, excluding their spouse or their husband or wife. There were a total of 112 handshakes. How many couples were there? So, for this one, suppose we have n couples. Then there will be 2n people, and then after there are 2n people, each person shakes hands with 2n minus 2 people, which is the 2n people, but excluding themselves and their spouse. And then this divided by 2, these two cancel, and this will just give us 2n times n minus 1. Oops, sorry. 2n times n minus 1. Okay, so that's the amount of handshakes. And then this would equal 112. These two cancel. They become 56. Using trial and error, we can find that n equals 8. So there are 8 couples. For the second one, we can use a bunch of ways to solve the problem. So first, using the arithmetic series formula, it's just first and the last numbers, which is 61, divided by 2. So these two will give us 30. So it's 30 times 61. And then since 61 is a prime, as you can check, we have that the prime factorization is 2 times 3 times 5 times 61. And obviously, the largest prime is 61. And the second one, we have that for the second solution, we can just do 2, 3, 60 to 60 numbers. And then we can write the reverse here. And then we find that there are 61 rows, and each row has 60. And then after that, we divide by 2. So it's 61 times 60 over 2. So obviously, the largest prime is just 61. Questions? If no questions, then I'll move on. So this is the fundamental counting principle. The fundamental counting principle states that if there are m possibilities for one event and n for another event, there are mn possibilities for both events to happen. But there's a flaw in this, because this is only true if the two events are independent. So if the first event, if the second event depends on the first event, then this will not be true. But if it doesn't depend on the first event, then this statement will be true. So, for example, this will be true if we have that this will be true if the first event this will be true if the first event doesn't depend on the second event. Then this will obviously be true because we can just choose one of them from the first one and choose one of them from the second one, and there will be mn possibilities. So I'll give you guys a few minutes to solve these
Wait, Lewis.
Yeah.
My chatting thing kind of broke, so I can't answer the third one.
Wait. Can all of you guys retype all the answers you have written in, because I lost my internet connection and I had to leave the meeting. And now I can't see the messages you sent before.
It still doesn't let me send. Lewis.
Then maybe switch the choosing to everyone and then back.
Yeah. BTW, that's a 10. You're muted.
Oh, sorry. So, going over the first one, we can, for 2 coins, we have 2 and 2, which is, and for the 1 6-sided die, it's 6. And for a 2 20-sided die, it's 400, because 20 times 20 equals 400. Multiplying them out gives us 9,600. And then for the second one, the sizes are S and L. With or without cheese, C or cent. And then the 5 sandwiches, 1, 2, 3, 4, 5. Okay? And then since all of them are independent, we just have 2 times 2 times 5, which is 40. 20 of them sandwiches we can make. And for the third one, it will just be a 6-sided die is rolled 3 times and results are recorded in order to make a 3-digit number. How many numbers greater than 400 are possible? So, the first digit or the first roll can be 4 or 6. So there are 3 choices for the first roll. The second roll and the third roll would have 6 possible ones. So multiplying all of them out gives us 108. So our answer is 108. Any questions? Okay. So if no questions, then that would be it for today. And also for the homework, I'll post it later. And remember to read the problem carefully. The homework, we have you answer in A, x minus b times x minus c, where b is greater than c. So the correct answer should be A times x minus 8 times x minus 5. But a lot of you answered as A times x minus 5 times x minus 8, which is incorrect. So just remember to read the problem carefully next time. Okay? And now that will be it for class. You guys may leave.
Bye. Bye.
Bye, bro.
Thank you.
See you later, little bro.
Bro, what the heck? Bye, Lewis.
Yeah.